Okay, hello. This is the Unit 7 MCQ test corrections. See, I got 8 out of 10 on this. This is the one of the ones I got wrong. So here we have a block is attached to a vertical spring right here that is attached to the ceiling of an elevator as shown in the figure on the left. The elevator is accelerating upward with a constant acceleration. Oh, okay. And the block is at rest with respect to the elevator. The block is then displaced a distance d from equilibrium and released from rest at time t equal to 0. Motion detector on the floor of the elevator records the distance of the block from the motion detector as a function of time, which is represented in the graph on the right. The elevator then comes to rest and the block is returned to its equilibrium. The block is again displaced a distance d from equilibrium and released from rest. Which of the following correctly indicates how the precision time graph would be different at all if the graph above? Okay, so this graph is the one where it's in the elevator, I believe. So this is how the graph is affected in the elevator, and then sorry, and then how would a graph without the elevator moving be different? So okay, yeah, so I put this one because I thought since if the elevator is going up, then the FG. Wait, okay, so I thought since okay, I just had the wrong read. I think I thought that since it was going up, then like the parent weight would be lower, but the parent weight would still be higher, even if So yeah, I'm not sure how I even got this one wrong, but see the answer here is A. The graph would shift upward because the equilibrium position is shifted upward. Spring constant remains the same. Okay, so since it's going up, then that means there's a force that's applying up and going against the FG. So that means um so that means the equilibrium point should be higher than it is without the elevator. And if the equilibrium is higher, distance of the block. Oh yeah, if the equilibrium. Wait. I don't know. I still don't understand. The spring must be exerting an upward net force and therefore be stretched further from its unstretched length. Um, I think okay, so it stretches it more, so then, or it compresses the spring more, so then when the spring um it oscillates the the displacement from the equilibrium point is higher since it gets compressed more, so it should get stretched more. I think that's what it is. So that means if you remove the extra force, then the spring um won't stretch as far, so that's why it goes up. So that's why it goes up. And then the other question that I got wrong, this one. A horizontal spring of string constant k equals 300 is compressed at a distance x equals 0.1 meters by 10 kg block. The block is then released and allowed to slide along a horizontal table. The coefficient of kinetic friction between the table and blocking table is mu equals 0.2. Which of the following is most nearly the magnitude of the initial acceleration of the block just after it leaves from rest? Yeah. Okay, so okay, I believe I remember this question. I did. Hold on. So I think we do our free body diagrams mostly horizontal. So we have let's say it's going towards the right. We have the spring pushing it to the right. So we have the force of the spring minus force friction equals ma, and then force of the spring is I forgot. K delta x. So we have our k here 300 and our delta x 0.1. So 300 to 0.1, 30. Right, so 30. And then force of friction is UFN. And you know Fn is equal to mg because it's not moving up or down. So it's mu mg. And then g is 10. M is 10. 0.2 20 for MA. Wait, 0.2, yeah. So I got 10 equal to MA, and then the mass is 10 as well. So this is A equals to 1. Okay. So here I just got the well. Okay, I don't know how I got this answer. I might have like done the math wrong or something. Then that's how I got 5. But yeah, I don't know how I got it because right now I just got 1, which is our answer. So yeah, that's it. All right, thank you.